Good afternoon, students. Today we are going to see the topic of about classical problems in synchronization. In UIS, used to test, analyze, and solve concurrency issues like deadlock and race conditions, starvation, when process share the resources simultaneously. So the basic problems are producer-consumer problems and the reader-writer's problems, dining philosopher, and sleeping barber problem. Anyone explain about producer-consumer problem?
Producer consumer problem. It is a classical example of synchronization of a problem. It demonstrates how process or thread can safely share the resources without any conflict. This process belongs to the process synchronization domain, specifically dealing with the coordination between multiple processes sharing the same buffer. Here we are going to take two things now. One is producer and another thing is consumer. Here producer provides the data items and place them in the shared buffer, which has a common location. And the consumer removes and processes the data from the buffer which is placed by the producer. Here how it works means producer checks if the buffer is empty or not before placing it. Mutex is a thing called only one process can access the buffer at a time. Not multiple processes can access the buffer at a single time. Mutex ensures that. And the consumer checks if process is there or not. In the real-time example, we can take as an chef and the waiter. Here, chef prepares the dish and places them on the table. Here, the table as a buffer. Chef is a producer, and the waiter takes the food and delivers it to the customer. He acts as a consumer.
Okay. Who will explain about the reader's problem?
Me. It's a classic synchronization process. It is like a shared data access to two of them, readers and writers. It has some rules. Many readers can read the file at a time, but when a writer wants to write something in the file, no readers are in the no readers reading the file, then only the writer can write the problem file. It has three types of variables. Mutex, it controls the reading count, and WRT controls the access to the shared data, and the reader count, number of readers currently reading the file. Example of this, we can take the library as an example. Students as the readers and librarian as a writer. Many students can read a book at a time. So one book is placed in the middle of the table, all of them can read the book. But if a librarian want to take the book and rearrange or updating the book anything, all the readers must leave the book, and then only the librarian can access to the book. This is like the reader's problem work.
Okay. The next problem is dining philosopher. Explain.
Let me explain dining philosopher problem. Let's take this as an example. Like let's take a real life example. Like we are all sitting in a round bench, right? Just think or imagine that we are in a hotel or in a restaurant where the chopsticks are placed around us. Like if here 6 persons are sitting, right? Only the six chopsticks are placed in this table. While we are all thinking that let me eat the food by using the chopstick, okay? But there are only 6 chopsticks. So everyone used to think who will take the chopstick first, who will eat the chopstick first. This time will be empty. Let's compare this to a process in CPU. In a CPU, when the process are waiting or like thinking that another process will execute, the memory will be in empty. Yes. Same as in this, we are sitting in a round bench. Only 6 chopsticks are placed for the 6 person. So everyone used to think who will take the chopstick and eat first. Let us think. Let me take the chopstick first, or everyone used to take the chopsticks first. Like every 6 person taking the 6 chopsticks. So there will be not a chopstick for a right hand. The normal rule of the chopstick is to take two chopsticks, right? Like we used to take the two chopsticks to eat the food. In a left hand one chopstick and then right hand one chopstick. But in this table, there are only 6 chopsticks. So if the all 6 persons takes one chopstick, everyone used to have only one chopstick. There is no another way to eat the food, right? Like we only have one chopsticks with everyone. There is no 2 chopstick. So here the problem will arise: who will eat the food first? It is a major problem that occurring in the dining philosophy problem. So everyone have only one chopstick. We cannot eat the food by only one chopstick. So we need another chopstick. So to solve this problem, we are just replacing a one person, like one process or one person. If the table is surrounded by 5 person and 6 chopstick, it will be easier to access or eat the food, right? If everyone used to take one chopstick, the another chopstick will be remaining. So every person used to, like first person, like let's take him. He is taking a one chopstick. If the space will be empty, the another chopstick will be there. So he used to take two chopstick and eat the food. Then replace the same chopstick in that place. Next, the next person will take and use the same chopstick. In this, we are comparing if the one process is using the memory, it should come back to the place and allows the another process to use the same memory. This is known as a dining process.
Okay, let us conclude this with a small assessment. And we'll list out the problems which is happened in synchronization. What are the problems are in synchronization?
Deadlock loss of data.
Okay.
Deadlock comes under the main major problem, and inconsistency. These are the problems.
Okay. What are the synchronization variables in readers-writers problems?
WRT and recount.
Okay. What is the condition for dining philosopher problems while using the chopstick and the philosopher?
The data, the process should comes back to the CPU after completing.
Yeah, and it could be the condition. There could be a condition. It's equal number of chopstick and number of philosopher should be equal. That is the major condition in dining philosopher problem. Okay, thank you.
Thank you.